Hey everyone, what's up? This is Pedro from Rainbow, and today we're going to build an NFT minting site front-end using RainbowKit and wagmi. Now this consists of three different parts. The first one is a smart contract that will allow us to mint an infinite number of an NFT. This is already done and we're not going to cover this in this video, but we're going to be using it. 2, we're going to use RainbowKit to connect with a wallet. And 3, we're actually going to dive deeper into wagmi to see how we can use its hooks to interact with the smart contract. So let's jump right in. This is what the NFT mint site looks like. It shows us the number of NFTs that have been minted. This data is stored in the smart contract. It allows us to connect with a wallet, and only then it shows us the mint button. We can then go ahead and mint this NFT, wait for the transaction to complete, and then we can see how the number over here has updated, and we can see the transaction on Etherscan or on Opensea. In order for us to create an NFT minting site, we need a smart contract. So for this demo, I'm going to be using a very basic ERC1155 contract that keeps track of the total supply and of course allows the users to mint. This contract has already been deployed to the RainbowKit test network under this address. And finally, we're going to need the contract's ABI, which can be found in the RainbowKit GitHub repo under the examples directory with next mint NFT and contract ABI.json. I already have a Next.js app running from the previous videos, but all I've done to this is added a little bit more markup, some styling, a dummy mint button which currently doesn't do anything, and then the card component which we're going to flip once the NFT has been minted. And this is how the app is currently looking. As you can see, it's still missing some features and some logic, but in the next few minutes we're going to add that in with wagmi. The first thing we'll do is create a contract ABI.json here and copy the ABI from the GitHub repo because we're going to be needing that later. And then we're going to update RainbowKit's configure chains function to use the RainbowKit chain, since that's where our contract has been deployed to. So let's talk about wagmi. Wagmi is a collection of React hooks that contains everything we need to work with Ethereum. It offers a really nice developer experience and it makes things that were previously quite difficult super easy. In fact, even RainbowKit uses wagmi internally. And today, we're going to be using some of its hooks to do contract reads, contract writes, and even wait for a transaction to complete. Let's start off nice and easy by only rendering the mint button when we know that there is a connected wallet. We can do that with the help of the use account hook from wagmi. So we're going to import it and then call it, and from the object it returns, we're going to pick the isConnected boolean. We can then use this boolean to conditionally render the mint button. We're now going to actually add the mint functionality to the mint button by importing the use prepare contract write and use contract write hooks from wagmi. We'll start with a use prepare contract write hook. That's basically going to set some things up for us, so when we actually mint, our users will have a much faster experience. So this hook accepts an address or name property. This is the deployed address of our contract. It then accepts a contract interface. So let's import the contract interface from our contract ABI.json. And lastly, the function name, which is mint. And what we get back from this hook is a config object. We can then call the use contract write hook, passing in the config. And from that, we're going to get the write function, which we'll rename to mint, and the isSuccess boolean that we're going to need to flip the card later. We can now go to our button and add the onClick handler to call the mint function. And finally, we'll flip the card when its success is true. Okay, let's switch back to the app and see how this is working. We can click on the mint button. We'll then confirm the gas fee. And there we go. Our NFT has been minted. This is a really good start, but there's a few things that we can do to make this even better. For example, notice how the state of the card flips the moment we confirm the gas fee. This is not quite accurate because the transaction is still pending. So let's enhance our UI to actually track the state of our transaction. We'll also track a few more states that we're going to add to the mint button here to give users a better experience. Alright, so let's do it, shall we? We'll start by importing the use wait for transaction hook. We can then call this hook passing in a hash. Now this hash we can get from the use contract write hook. We're gonna get the data, we're gonna call it mint data, and then we can pass in mintdata.hash. This hook returns an isSuccess boolean, which we're going to call TX success for transaction success. And then we're gonna create a local variable over here called isMinted, and we'll set it to the TX success boolean. While we're here, we're also going to pick the isLoading boolean from useContractWrite, and we're going to call that isMintLoading, and we're going to rename isSuccess to isMintStarted. And now that we've got all of these states, we can start updating the UI. So first thing we'll do is disable the button when isMintLoading or isMintStarted. Then we'll add a data attribute called dataMintLoading, and we'll set it to isMintLoading, and another data attribute called dataMintStarted, which we'll set to isMintStarted. We're going to use these data attributes to change the styling of the button based on these states. Then we can also update the text of the button based on those states. So when isMintLoading, we'll set it to waiting for approval. When isMintStarted, we'll set it to minting. And when it's not loading or when it's not started, we'll just set it to mint. We can also use the isMinted state to only render the button when the NFT has not yet been minted. And finally, we'll flip the card based on the isMinted state. Alright, so let's take a look at how it's looking. We click on the mint button again. Now we see waiting for approval. Once we confirm the gas fee, the state of the button changes to minting. And when transaction has actually completed, the button disappears and the card flips. What we can do next is actually go ahead and construct the Etherscan and Opensea URLs. We can build the Etherscan URL using mintdata.hash, and we can build the Opensea URL using config.address or name, which is our contract address, /1, which is our hard-coded token ID. So now we can go back to the app and we can click on Etherscan to get taken to the transaction details, or we can click on Opensea and get taken to the NFT page. And now the last thing left for us to do is let our users know how many NFTs have been minted so far. We can do that using the use contract read hook from wagmi. So let's import it, and then we can call it, spreading in our config, and then the function name, which is total supply, and we set the watch flag to true. That way this value updates automatically. This hook will return the data, which we'll call total supply data. And because we want to keep the UI up to date, we're going to create a React state, and then we're going to add a React use effect hook so we can update our state every time the total supply changes, and that way our UI can be rendered. And using our state, we can render a paragraph letting the users know how many NFTs have been minted so far. And that's how we can build an NFT minting frontend using just a few lines of code. To learn more about RainbowKit, visit rainbowkit.com And to learn more about wagmi, visit wagmi.sh. Cheers.